Hey everybody. So today we're talking about graphing again, but this time it's not just equations anymore. We're graphing linear inequalities. Learning objective for today, I can graph inequalities on a coordinate plane. When graphing these inequalities on a coordinate plane, when graphing linear inequalities, there's two big things that are different from graphing regular equations. Wow, excuse me. First of those big things is the symbol tells you what type of line you're going to draw. In equations, it was always a solid line. In inequalities, it might not be. And it's the same reason as our open and closed circles when it came to inequalities. If we were not underlined, it was an open circle. Now it means it's a dotted line on our graph. If we are underlined, meaning it is or equal to solid line on our graph. The second thing we got to keep track of, the type of shading. Remember, with our inequalities, we had open or closed, and then we had the inequality either going to the, well, that's my left, I think that's your right, and then the opposite direction. Well, now in your coordinate planes, it's kind of the same idea, but you're thinking I'm either shading above or I'm shading below based on the symbol that you get. When you get that y value all by itself, just like how we get the variable on the left side and then it tells us if I go right or left, the symbol here is going to tell you if I'm shading above or below. If I'm greater than or equal to, if I'm greater than, of course I'm going to be above. I'm talking the greater numbers. I'm talking the bigger numbers. I'm above my line. If I'm talking less than or equal to, well, it's less. It's smaller. So I want to be everything below that line. Two big things to remember, and you can find them right away by looking at your symbol given to you in the problem, whether it's solid or dotted, whether it's above or below. Let's take a look. Example number one. I like working with this one first because it's such a different type of equation, such a different type of line, but I want to show you and compare it to our regular inequalities. If we had a regular inequality here and we weren't graphing on a corner plane, we were just graphing it on a number line, all I would have to do is put my value down. It says x is less than or equal to 4. So I put 4. And then I'm looking at what type of circle I have. Well, since it's less than or equal to, since we're underlined here, that's a closed circle. And then which way does that inequality go? Well, since it's pointing towards the left, since it's less than, we want all of the smaller values. We want everything going towards the left. The reason we do this is to kind of show you to compare it on a coordinate plane. This is just one line, one horizontal line on a coordinate plane, which got us 1 point and one line going in the less than direction. But what if I don't have just one horizontal line? What if I have an infinite amount of horizontal lines? At least for this graph, you could visualize I have 1, 2, 3, 4, 5, plus another 5, plus the middle. I have 11 different points here. How do you think that would look for all of those? It would just continue with these points closed, and then they're all going less than, so they're all going in this direction. And that's exactly what happens here on our coordinate plane. When I'm graphing that line x equals 4, that means I have on x a straight vertical line. Since it's less than or equal to, it means I have a solid line at that point. And since I'm everything less than, I'm shading everything towards the left. So it's taking our idea of inequalities and just expanding it out to get every single point in between. Why can't I get every point in between, not just the dots like this one? It's because I'm less than or equal to. So all of these dots here become just one solid line. And then I shade everything on this side. Make sense? Let's see it again in a more typical fashion. Let's see it again. This time we're looking at example 2. We have 3x minus 4y is greater than 12. First thing I want to do, I want to graph this in slope-intercept form. So I want to get that y value all by itself. I have 3x minus 4y is greater than 12. I need to solve to get the y all by itself. Now, we were doing this before in delta math. Hopefully, we could do it still. There's 2 steps. I got to get rid of that 3x, then I got to get rid of that negative 4. Move the 3x to the other side by subtracting it, which then makes it negative 4y is greater than negative 3x plus 12. Now I get rid of that negative 4 by dividing it, and I divide everything by negative 4. When dividing by a negative, switch your inequality symbol around. So now I have y less than. Negative 3 divided by negative 4 doesn't reduce, but the negatives go away. So I have 3x over 4. 12 divided by negative 4 does reduce, and it becomes negative 3. So my inequality for this problem is y less than 3/4 x minus 3. Now I can start putting my points down to get this graph. Thinking about slope-intercept form, I have my y-intercept, I have my slope. There's my y-intercept point. There's my slope. I took the negative 3, put it down y-intercept. Then I counted with the slope. 1, 2, 3. 1, 2, 3, 4. I have my points. I could draw my line, but we have to pay attention now because of the inequalities. Am I solid or am I dotted? Since it's only less than and not less than or equal to, I am a dotted line. Do you see the difference? Do you see what I mean now by dotted line? Dotted, this says dashed, same kind of thing. It's broken up. It's not a complete line. It's not solid. Now that we have this, the last thing we need is the shade. Am I above or below? Since I'm less than, I'm below. So notice that shade. Everything below the line, it's shaded. Now I'm done. Example number 2. Example number 3. Y is less than 2/5 x on a coordinate plane. Y less than 2/5 x. It's already in slope-intercept form. The y is already by itself. Now, the tricky thing with this one is that they don't have a constant. There is no plus or minus any number. That's a y-intercept of 0. So we could put a point at 0 and then move with our slope that 2/5. So I have my point here at 0, and then I'm going to go up 2 and run over 5. So my 2 points are going to be right here and over here. Now, looking at the symbol, am I solid or am I dotted? Well, since I'm not underlined, since it's not less than or equal to, I'm a dotted line. Last thing we need to look for is the shade. Look at your symbol. Is this greater than or is this less than? It's less than. Since it's less than, we want everything below. So we shade everything below. There's my graph for this inequality. Taking the idea of our simple inequalities in graphing just off of a number line, expanding it to make the whole coordinate plane, and following a similar set of rules. Open versus closed now is solid versus dotted. shading towards the left, shading towards the right is now shading above versus shading below. Two extra things you got to pay attention to when it comes to graphing. Hopefully you guys are good to go. Couple last second questions here for you. You have two problems here. All I want you to do is tell me, for number one, is this inequality going to have a solid or a dotted line? For question number two, is this inequality going to have a solid or a dotted line? And then my last two questions for this video, guys. Same lines, but now you need to tell me, are we talking shading above or shading below? Now question number two, are we shading above or are we shading below? Really, those are the only two differences. Those are the only two big things that changes from just graphing in regular linear equations. Find the y-intercept, find the slope, draw your line, graph. With inequalities, two extra things. Is it a solid or a dotted line? Are we shading above or are we shading below? Hopefully you did good with this stuff. If not, shoot me an email. Let me know what's going on. That way I can try to answer some of your questions. We'll have practice problems with this, so we'll be able to pick it up. But the more we know, the better we'll get. Alrighty, guys. We'll talk to you all later.